A very good evening, everyone. I'm Kiran. I'm Kiran from Atal Innovation Mission. We welcome all our young innovators tuning into the Knowledge Hub session. This is the season 4 second episode. Today, we are thrilled to begin the discussion with this exciting topic, rapid prototyping with Tinker blocks. This is the second series of what our regional mentor of change, Kiran Kumar, covered on the last week. That was smart tinkering with Tinker blocks. So we are honored to have with us Shri Kiran Kumar, an award-winning innovation leader with 29 years of experience, known for shaping ATL entrepreneur, mentoring young change makers, and driving technology-led innovation ecosystem across the country. He will be guiding us today on how to transform ideas into working prototypes within minutes. And this is an unmissable opportunity for every budding entrepreneur and innovator. So let's dive right into the session and invite Shri Kiran Kumar for taking us through. Over to you, sir.
Thank you. Thank you so much, Riddhi, for the setting the context and for the introduction. I'm very happy to be back with everyone. Good evening, everyone. I hope many of you have attended my previous session last week, um, where I talked about Tinker Blocks, which is basically a rapid prototyping toolkit that ATL and non-ATL students can build on their own. So this is in continuation with the same series of sessions. This is the second session where I'm going to go dive a little deeper into the Tinker blocks and basically show you how you can build your own Tinker blocks. And I'll also do a few demos, live demos, so that you can see how Tinker blocks are built and how Tinker blocks can be used to rapidly build working prototypes in just minutes rather than in hours or days or weeks, right? So that is what the promise of Tinker blocks is. Let me quickly show you some of the Tinker blocks. Let me unshare my screen and hope you can see me. Last time I showed you a few blocks like these. Of course, these are cubical blocks. This is called as a power block. What I put is some rubber bands around it so that it can be easily taken out and put back. This is called as a processor block. We put a small microcontroller. It could be an Arduino or a Node MCU board inside this. Okay, and this is a fan block. You will see actually a DC motor with a fan, a propeller fan attached to it. So you will have fun, interesting projects to do with these kind of blocks. This is called as a temperature block. You must have seen, some of you students who have been to the ATL, you must have seen this DHT11 temperature and humidity sensor. So this is the temperature and humidity block. And the way to use these blocks is all you have to do is just plonk one block to the other. You see these pins here? Can you see these pins? And you just have to plonk one block to the other like this. Or you could just plonk another block to like this, and maybe another block like this. And we have something called as a patch cards, which are basically wires like these. And we just had to plug, let's say you have some data pin here, you just take this and connect it to the processor block so that the data can flow from the processor block to the actuator block, or from the sensor block to the processor block. It can send the data, and this has a Wi-Fi connectivity inside. It can send the data to your web application, mobile application, IoT platform, any other external source. So this is how you build different kinds of blocks. These are like Lego blocks, and you can just take this out and boom, this is how you can plug them in or plug them out. Okay, makes it very easy, very rapidly you can build working applications, because whatever circuitry is needed for building these blocks, you're going to make them once and you're going to reuse them again and again. So that is how you're going to rapidly speed up your tinkering or innovation projects. All right. So you've seen what these blocks are. I showed you these blocks last time. Let's come back to the slides and let me quickly show you a few more things. So I hope you have attended the previous session. If not, you can scan this QR code and you will be able to watch my previous session where I talked about the promise of Tinker blocks, what they are, what can you do with them, and all those things. Okay, this was like about 30-40 minutes session. So in case you missed it, please watch this session as well. Okay, because that will give you a better context to what I'm talking in today's session. And let's do a quick recap in the interest of students who have joined afresh for this session. Maybe I've missed the previous session. So what are Tinker blocks? It's basically a rapid prototyping toolkit that you as a student or a teacher in your ATL or a non-ATL school, you can build it yourself. What is the purpose of this? It is to speed up your tinkering or innovation projects. How are we going to do this? We are going to put some sensors, actuators, microcontrollers in different colored blocks, which we call as, which is basically in the form of cubes. And within these cubes, we put the sensors, devices, whatever, one per block, and we put the necessary circuits. And we make it easy for children to plug one block to another block to build a working application or a prototype very rapidly. And we have two types of blocks. One is called as a virtual block, another is called as a physical block. The physical blocks are something that you are seeing in this picture here. You can touch and feel them, whereas the virtual blocks are software-based modules. Okay, and we can integrate these blocks with IoT, with artificial intelligence, with augmented reality, with blockchain, with chatbots, with mobile and web applications, and a lot more things. You can do very, very interesting things with these blocks. And it primarily, if you see how does it help the children, the beginner tinkerers and innovators in the ATL often have key challenges. That is, they find tinkering very hard because they don't understand the electronics, they don't understand the devices, they don't understand the pins, they don't know how to connect them, and they always need support and guidance to do them, initially at least. But these blocks hide all the technological complexity. The circuits are not visible to you because they're inside the block, and all you have to do is just connect one block to the other very easily, like Lego blocks, and very quickly you can build applications without having to worry about the technological complexities involved in building these kind of circuits. All right, so that is what Tinker Blocks was. We talked about it last time. We also talked about the 4 different types of blocks: a sensor block, which can contain any DIY sensor, whether it's the fire sensor or a motion sensor, whether it is a temperature sensor, whatever, an actuator block like a buzzer or a DC motor or a servo motor or something else, and a power block which provides power supply to all the other blocks, and a processor block which basically has a Arduino or a Node MCU kind of processor which provides the brain or the intelligence to all the other blocks to make them work, and we can put Arduino code into the processor block to make it work. Okay, this is what we understood last time, right? So this is a quick recap. And we also saw that we could just snap one block to the other and connect some patch cards to them, and boom, the entire working prototype will be ready in just a minute or two. You don't have to spend a lot of time rigging up your circuit and spending time figuring out how to connect this pin, how to connect that wire. No, none of those things are required now, because you can just snap the blocks into place and it starts working. This is also what we saw, right? And we briefly touched upon the virtual Tinker blocks as well. Although I didn't explain in great detail, virtual Tinker blocks can be the software modules that can be interfaced with the physical blocks. The physical blocks contains the sensors, actuators, microcontrollers, and things like that. Whereas the virtual blocks contain the web apps, mobile apps, chatbots, IoT applications, AI applications, AR applications. It could be Gen AI applications, voice assistants, or any other application. Any application that can be reused again and again, they can all be part of your virtual block repository. And all you have to do is plug those virtual blocks with the physical blocks, and boom, your virtual rapid prototype can be ready in just minutes. Initially, it will take you some effort to put these blocks in place, but the more number of blocks you have, the more interesting, creative things you can actually build. All right, so these are some of the things we looked at last week. And now today, we are going to show you how to build one of the Tinker blocks. Okay, today I'm going to show you how to build a servo motor block or a servo block. I'm sure many of you must have seen what a servo motor is. If you have been to the ATL, a servo motor is a motor that doesn't rotate like a DC motor continuously. You can make it rotate in small angles. You can ask the servo motor to rotate like 15 degrees or 20 degrees or 22 degrees. These are used primarily in robotic applications. So a servo motor block will be very interesting to build. Let's see how to build this. All right. So let me show you a quick demo of the resource materials that we need. Okay, let me unshare my screen and then come back and show you the resource materials we need. First of all, to build a servo motor block, you need something called, like you need a kg cardboard sheet like this, right? Simple kg cardboard sheet that you can buy in any store. So for the any sensor kind of block, we use an yellow colored kg cardboard sheet, whereas for an actuator, we use an orange colored sheet. And for building a power block, we use red colored sheets, and for building the processor block, we use blue color sheets. That is how we are going to use it. Apart from that, we also need something called as a corrugated sheets. Can you see this corrugated sheet? This is a slightly thicker. It's much thicker than a kg cardboard. It can be typically 3 mm in thickness or 5 mm in thickness. This is a cardboard corrugated sheet. So if you have these sheets, you can cut them into pieces and make a cube like these blocks. If you want to make a block, you need to cut these pieces and make them into a block. Okay. But we are going to use this more as a supporting material, not as the primary material for building the blocks. So this is one option. Or the second option for you is something called as a plastic corrugated sheet. Can you see this plastic corrugated sheet? It's 5 mm in thickness. This gives you much bigger, more strength than the cardboard corrugated sheet. The cardboard one can bend easily, but this one will not bend so easily. So this is much stronger, but of course the cardboard one is more eco-friendly, whereas the plastic one is not. So I leave the decision to you of which kind of sheet you want to use for building your Tinker blocks. All right. So with that said, let me also introduce you to some of the components, the electronic components, the electrical components that are required for building the blocks. First and foremost, you need a servo motor. This is a servo motor. Can you all see this servo motor over here? This is how the servo motor looks like. So you need a servo motor to build a servo block, of course, right? And we also need a switch, a small device like a switch, which can be pressed on and off, which will make the block turn on and turn off. And we also need something like an LED to make the, for people to know whether the block is powered on or powered off, right? And along with the LED, you also can use a resistor, a small resistor, a 330 ohm resistor like this. Or in addition to that, you will also need something called as a female barrel connector, something like this. Okay, hope you can see this. This is used for connecting one block to the other. And the male barrel connector, something like this. The male barrel connector is also used for connecting one block to the other. So every block should have a male and a female barrel connector. And we also need to have something called as a banana pins, banana connectors, something like this. We typically use a blue one, but I'm showing a black one here. But for data pins, for connecting the data pin of the sensor to the processor, we will make use of a banana pin like this. Okay, this is a female banana pin. And of course, you will also need a male banana pin like this. Okay, this is used as part of the patch cord. And of course, you need some jumper wires and things like these. All right, so these are some of the materials that you'll need for building the servo motor block. Okay, let me come back to the slide very quickly and show you some of the, I'll do a quick run through of the materials. So we pick an orange colored sheet. I hope you can see this. I'm going to full screen mode. Okay, orange colored sheet. And you can either use a plastic or a corrugated sheet. And in case you are not able to see some of the materials I showed you on screen, these are the materials. You will need all of these materials. You can get most of these materials in your ATL. In case you don't get them, you can always buy it in some electronic shop, and they don't cost much money. So it's very low cost materials. And you just had to buy all of these materials. And once you have these, you can easily readily build the servo block. All right. Okay, let's go to the next one. So let me show you now the steps involved in building the servo block. How do we go about the step-by-step process? Okay, let me unshare my screen one more time and take you back to the demo. Okay, so how do we start building the servo block? What is the very first step? Of course, as I told you earlier, you would need a kg cardboard sheet. We'll start with this. So you take the sheet and do one thing. You will have to make some markings like this. What I've done is I've already done the marking and I have created I've taken an orange colored sheet, kg cardboard sheet, and I have done some markings on this. Can you see this? These are all the way exactly all of these. If you actually take all of these and fold it, it becomes a cube like this. Okay, it becomes a cube. So if you want to get a cube something like this, you need to cut a kg cardboard in this shape. Okay, you need to cut the kg cardboard like this. And what we are going to do is we're going to create a 7 by 7, 7 centimeters by 7 centimeters square to make this block. Okay, cubical block. And we have some flaps here which can be bent and which is used for sticking on the sides. So you'll need a few flaps as well. And this is how we are going to start with this. So first and foremost is to take a kg cardboard, mark these lines and then cut along the lines so that you get something like this and you fold it and it can become a block like this. But this is not enough because the kg cardboard sheet doesn't have enough strength to hold the things. If you try to plonk another block on top of it, it will just go inside, right? It will just break like this. So this is not going to serve the purpose fully. So that is where we are going to do something more. As I told you, we are going to use corrugated sheets for improving the strength of the blocks. Okay, now let me show you a block in which I have already affixed a few corrugated sheets. So all I have to do is take some sheets like these, cut the corrugated sheet into smaller pieces and stick them on this kg cardboard. Okay, so you'll have to fix on all the 6 sides, 1, 2, 3, 4, 5, 6. On all the 6 sides, you're going to fix different sizes of corrugated sheets. In my case, I have used all the plastic corrugated sheets because it gives me enough strength and it'll be more durable and it can work for multiple days, weeks or months. The cardboard one can break apart if the students use it roughly. Okay, so I would prefer if you can use a plastic corrugated sheet. These are also available on Amazon or any other store. You can just go buy them. It doesn't cost you much money either, and you can use them. Okay, so this is how we are going to stick. And if you see, this is a 7 by 7 centimeter corrugated sheet. This is also 7 by 7. This is a 7 by 6. This is also 7 by 6. This is 6 by 6 and 6 by 6. And we need to leave some space between them. Otherwise, when you fold them, you will not be able to uh, all of the blocks, these corrugated sheets will press on each other. So that should not happen. So it should easily fold like this, should easily fold into a cube like this, right? So that's the whole purpose. So it should become a block like this. Okay. So once you put the corrugated sheets like this, what is the next step? So the next step is you need to make some holes because you need to fix the servo motor, you need to fix the switch, you need to fix the barrel connectors, the banana pins and things like these, right? So for that, you're going to make holes like this. Okay, so you're going to make some holes like these. So here is where on the top you can connect the barrel connector, female barrel connector, male barrel connector here. You can connect a switch here, you can connect a data pin here, and you can connect some sensor or some actuator here. You can put an LED here. On these two sides, we'll leave them empty because we are going to put some QR codes on the outer surface. So this is how it looks on the inner surface of the block. This blue colored corrugated sheets will not be visible on the outer surface. Outer surface actually looks like this. Okay, this is how the outer surface will look like. Right, outside you just see an orange color with some holes here. Right, that's all. You don't see anything more than that. And when you fold it, it can become a cube. Right, I showed you earlier. So you just make a cube out of this. But what is the next step after this? You have made the holes. Now you can take one of these, let's say a female barrel connector like this, and then you can insert it into this hole and you can push it. So make sure the holes are not too loose, too big, otherwise this will not fit tightly. Okay, so you need to push this inside, push it further inside, and then you can insert it. So likewise, you need to insert all the components one after the other, and then once the components are inserted, then you can do the wiring as well from inside. Okay, let me show you how it is actually built. So you have seen the servo block earlier, right? So I'm going to remove this rubber band and show you what is inside this. Okay, so on the outer surface, you see the servo block has been mounted here. There's a male barrel pin connected here, and then there is a switch connected here, a data pin for the servo block to get some command from the microcontroller, and also there is a female barrel connector. All of these are mounted. Okay, so in the holes that we made earlier. And if you see on the back side, this is how it looks like. The wiring is all done. So the wiring is done between the between these components. I'll show the circuit diagram also. You don't have to worry how I've actually connected them. You can I'll show the circuit diagram and you can then figure out how these connections are actually made. All right. So once it is done, you just have to put them back and it becomes a servo block once again. Right. So this is how we are going to build a servo block. Now let's go back to the screen and the slides, and I'll show you once again what we have. So to do a quick recap of what we just showed you. So you start with a kg cardboard sheet, 30 centimeters by 25 centimeters. Then you take a pencil and use a ruler to make these markings, 7 centimeters by 7 centimeter squares and some few flaps also. This is how you're going to make the markings on the kg cardboard. And after that, you're going to cut them with the scissors. Wherever you see the scissor markings, that is where you're going to cut them. So you're going to get the shape exactly like this, what I showed you earlier, right? And after this, you're going to fold them on the edges. Wherever there are edges, you fold them so that it becomes like a cube. But don't fold and make the cube yet because there are more steps, right? So we take a corrugated sheet, whether it is the cardboard corrugated sheet or the plastic corrugated sheet, just make sure it is at least 5 mm thickness because it should have sufficient strength. Take a size which is like 19 centimeters by 14 centimeters and then cut them further into 6 more pieces because we are going to fix each of these pieces inside the kg cardboard that we cut earlier. So 2 of 7 by 7 centimeters, 2 of 7 by 6 centimeters and 2 of 6 by 6 centimeters. Okay, so we are going to make so many cardboard corrugated sheet pieces. And once we have these pieces, all we have to do is go and stick them with a Fevicol or some glue. So the 7 by 7 pieces will go to the top and the third one, and the 6 by 6 will go on the left and right, and the 7 by 6 centimeter rectangular pieces will be put here and put here. Okay, so why we do this is because the kg cardboard doesn't have strength on its own, but we need to reinforce it. So we are going to put some cardboard sheets here, and on this we are going to make holes and mount the circuits. Okay, the components, and then we wire them up. Okay, this is how it looks, and the flaps you need to leave them free because they need to fold on the sides. All right. And then after this, you can fold it and becomes a cube like this. Okay, when you fold it, the flaps also go on the sides. So the next step after this is, okay, let me, so if you look at it, the inner side looks like this and the outer side looks like this. I told you this earlier. On the inner side, we are going to mount all the, first glue up all the cardboard sheets, the corrugated sheets. And on the outside, it just looks like plain orange colored kg cardboard. This is how it looks on both the front, the inner view and the outer view, right? And after this, we are going to make some holes, right? We talked about this also. We are going to make different sized holes. For a servo motor, you need a rectangular hole like this. For an LED, you need a small hole. Barrel connector, male barrel connector, you need a slightly bigger hole. The switch will have a bigger hole. The barrel connector also has a bigger hole. You make multiple holes. You need to take measurements and then make these markings, and then you need to make the holes. All right. And the hole has to be completely, it has to come out through the other end as well. So on the kg cardboard side also, you need to be able to see the holes. And once you do this, then you can mount these components on top of it. I explained this also. So the thing is, some of the components have to be mounted from inside, some of the components have to be mounted from the outer side. So in this case, all the components we need to mount from outside except the LED. The LED has to be mounted from inside, And all the other components you can mount it from the other side, from the outside view, from the KG cardboard, the orange colored side. From there we are going to mount them, and the pins of these components will be inside. Okay, only the components switch, the button of the switch will be visible outside, whereas the pins of the switch will be visible inside. Likewise, most of these will be like that. Okay, and after this you're going to do connect some wires. Take some wires, cut the ends of the wires and strip off the insulation, and either you can solder them at the edges or you can just insert them through the holes on these connectors and then twist them tightly, and also put some insulation tape. Putting insulation tape is very important because there should not be any short circuit. That is, the positive and negative should not touch each other. All right, so that is very important. Okay, so once this is done, your block is pretty much ready, okay, for operation. And this is how the circuit actually looks like for almost many of the blocks. Whether it is a sensor or actuator, most of the sensors have a VCC pin and a ground pin and a data pin. The data pin is always connected to the banana connector, whereas the VCC is connected through the switch to the positive terminal of the male barrel connector. Male barrel connector is the one which gets power supply from the power block. From here we take the positive, and through the switch it goes to the VCC. And from the male barrel connector's negative, we connect it to the ground pin of the sensor. All right, and similarly the LED also has anode and cathode, positive and negative. These two also should be connected to the male barrel connector's positive and negative. And likewise, the female barrel connector also has to relay the power supply that is coming from the male barrel connector has to be pushed to the female barrel connector also. So the positive and negative of the female barrel connector also has to be connected to the positive and negative of the male barrel connector. And that's it. This is how you do it. But most of them, the sensors and actuators, they have only 3 pins. It works like that. But ultrasonic sensor has 4 pins. You'll have to slightly modify. You need 2 data pins and 2 female barrel connectors. And some actuators like DC motors and all that, they also need relays. So you need to suitably modify the circuit diagram for certain types of actuators or sensors. Okay, but this is good enough for you to start with and build a few blocks. So, and once you actually assemble all the servo block, this is how it is going to look like. The servo motor will be visible on the front. There will be an LED and there is a female barrel connector. This is one view, and the male barrel connector is here. And you can see the LED here, over here, and there's a switch and there's a data pin here. Okay, this is how the servo block will look like. I already showed you how it looks, right? So apart from this, you also need to create a few patch cards. What are patch cards? They're nothing but wires with 2 male barrel connectors at either end, both ends of them, because these are wires that we are going to use for connection between the sensor block and the processor block, or between the actuator block and the processor block. I showed you these wires earlier. These wires provide the connectivity between the microcontroller and your sensor. Okay, so these are connected to the data pins on this actuator block or the sensor block. So these are things you also need to prepare. Once you do all of these, then you can start using them. Let me show you one more demo of the temperature block, how it looks on the inside. Let me unshare my screen and quickly show you how the temperature block looks like. Okay, so this is the temperature block you have seen, right? And I'll just remove the rubber band here. And if I were to open it up, this is how the temperature block looks like on the inside. It also, the temperature sensor is mounted here. There's a switch here. This is the switch here. There is the female barrel banana connector here. And then there is the male barrel connector over here, and there's a female barrel connector over here. And the circuit diagram that I showed you earlier applies for this as well. Okay, so very similar construct, and you just have to put them all together and put the rubber band, and it becomes a temperature block. Okay, so now let's come back and let me show you a few more things. So if you want to build a few more blocks, the approach is the same. Let's say if you want to build a fire block with a fire sensor on it, only everything else is the same except that you're going to put a fire sensor here. The fire sensor is mounted in place of some other sensor or some other actuator. That also has a VCC, ground, and a data pin. Everything else is the same. Okay, and the fire sensor looks like this on the outside. And the buzzer block also looks the same. Instead of putting a fire sensor, you put a buzzer here. The buzzer block looks like this on the outside, and this is how it looks on the inside. And power blocks looks little different. They are unlike the sensor blocks or the actuator blocks. In a power block, we are going to put only the female barrel connectors, because these female barrel connectors are used for connecting the sensors or actuators or the processor blocks to the power block, because the power block, as I told you earlier, is one to which all the other blocks are connected. So it needs to provide power supply to all the other blocks. So there are 6 female barrel connectors here, out of which one can be used as the input and rest of them can be used as the output. That means the input power supply to the power block will come from an AC to DC adapter, like a 220 volts to 5 volts DC output. So your mobile chargers and things like that. Mobile chargers nowadays have USB connectors, but you need to buy a connector which has a round pin. Okay, that can be plugged onto this, then the power block will get power supply and it can supply the power to all the other female barrel connectors here, and all the other sensors and actuator devices can be connected to the power block. And so pretty much you need to connect everything to everything here. This is a simple circuit. This is how it looks like. All right. Whereas the processor block is little different. It's going to have a processor. It could be an Arduino or it could be a Node MCU. Node MCU is very similar to Arduino, but is much smaller in size. So I would suggest you use a Node MCU kind of processor for your Tinker blocks. And all you have to do is take the power input from this male barrel connector, supply it to the V in and ground pins of the Node MCU. Okay, so the Node MCU gets power supply now. You don't have to connect a data cable through this. Okay, there's no need to do that. Only when you have to download or upload code, then you will need the data cable. Rest of the time, this power supply can directly work. Once the Node MCU is powered up, it can start running your code. And when the Node MCU has pins like D0, D1, D2, D3, D4, right? So we are going to connect the all of these data pins here, the banana connectors, to the pins of the Node MCU. D1 to the 1 pin, D2 to the 2nd pin, D3 to the 3rd pin, D4 of that Node MCU to the 4th pin. Likewise, all the way up to 8 pins. So D8 of the Node MCU will be connected to pin number 8 here. So this is how we are going to connect all of them and finally close the block, and it becomes a processor block. Okay. So this looks like a lot of wires here, but it's very simple to do, much easier. It is less time consuming to build than other blocks. So I'm going to give you tutorials. You can go through it in detail. You don't have to necessarily rely on these videos to know how to build these blocks. The tutorials explain to you every step in a very simple and easy to understand. Okay. Now that we have seen how these blocks are built, the different types of blocks are built. Now, once the blocks are ready, then it becomes extremely easy to build any kind of applications. If you want to tinker and innovate and build different types of working prototypes, it becomes extremely easy to do it. Okay, the hard part is done. Now the easy part starts. Now I'm going to show you how to build a fire alarm application using Tinker blocks. But before that, let's say you didn't have Tinker blocks, then how do you build a fire alarm application? A fire alarm application is something that should have a fire sensor and an Arduino board and a buzzer, and you need to rig up a circuit something like this with all these wires, and you need to understand the pin configuration, how the devices work. You need to understand the code, you need to write the code, everything, and make all of these. It will take you probably a couple of hours to build this, and then it has to work. If it doesn't work, you need to see why it doesn't work. Okay, so this is the hard way of doing things. But with the Tinker blocks, it's much more easier to do it. So all we need is these 4 blocks: fire block, buzzer block, power block, and a processor block. So we take these 4 blocks, plug one onto the other. All the blocks can be connected to the power block like this. Just connect the fire block to the power block, and likewise the buzzer block and the processor block, and you plug all of them together. And then after this, you connect 2 patch cards, because the fire block has a fire sensor. If it detects that there is a fire in the vicinity, it has to send the fire status to the processor block through this patch card, through this wire. Similarly, how does a buzzer know when to buzz? The processor block has to send a signal through this patch cord to the buzzer block and tell it to start buzzing, right? So these patch cards are used for sending the signals between these sensor blocks, processor blocks, and and similarly between the processor block and the actuator block. Okay, this is how you need to plug them all together. And once you plug them together, you need to upload a code to the processor block. This is a very simple Arduino code in which um, the code reads the one of the pins. The fire pin is the D1 pin, or the one which is connected to the first pin of the processor block. It reads the fire pin, and if it detects that there is a fire, it will turn on the buzzer for 5 seconds, and then it turns off the buzzer. And if there is no fire detected, it will turn off the buzzer. That is all it does. In fact, if you want to download this code, just scan this QR code and you will be able to download this very simple Arduino code. Okay. So what you have to do is download this code to your computer, then using an Arduino IDE or a Arduino Cloud Editor, upload the code to the processor block, which actually has a node MCU inside it. You have to connect a data cable, and this is a one-time activity. You just upload the code to the processor block, and after that you disconnect the cable, you remove your computer also. You don't need the computer after that, right? It's very simple. So after that, what will you be left with? Only the processor, these blocks and the patch cards. Now, how do you make it work? To make it work, you need to connect an AC to DC adapter like this, similar to your mobile charger. So you take this, connect it to the wall socket, and the other end you connect it to the power block. Now the power block gets power supply, and it's going to give the power to the fire block, buzzer block, and the processor block as well. Once all of them start working, then all you have to do is bring a flame, like a gas lighter or a matchstick or something, very close to the fire block. Okay. And once you bring the flame, what happens is the buzzer block starts buzzing. It starts making a buzzing sound like this. Okay. So this is how it works. You just plonk a few blocks, upload the code once, and you can reuse this project again and again in by multiple students in multiple projects. If you want a fire alerting system in your project, you just have to reuse these blocks again, right? So that is all you have to do. So once done, it can be reused a number of times. All right. Now I'm going to quickly show you a live demo of how this works. Okay. Let me unshare my screen and show you how to build these blocks, how to build the fire alarm system. So to start with, I'm going to take this power block, and to the power block, I'm going to plug this fire sensor. Okay. And I'm going to plug them together like this. Now they're holding together. Now to this, I'm going to connect a buzzer block as well. All right. So I'm going to take a buzzer block. Can you see this buzzer over here? I'm going to plug this in like this. Okay. And on top of it, I have plugged in the processor block. And I've already uploaded the Arduino code to this processor block. And all I have to do is take the patch cards, two patch cards, take one of the patch cards, connect it to the fire sensor, and connect the other end to the processor block so that it can send the fire status data. Similarly, the buzzer block should be connected to the other pin of the processor block, pin numbers 1 and 2. You saw in the code it was pin number 1 and 2. So now this is all connected, right? Now, where do I get the power supply? So I have a cable here coming from an AC to DC adapter, and the moment I plug in, you will see the lights going on. So I'll connect it from the back, and you observe tell me whether your lights are visible on these blocks. Okay, can you see that there is a light on this? There's a light on this. I don't know whether you can observe it. There is a light glowing here, LED is glowing here, and there's also an LED glowing here. Okay, now we have the circuit working. How do we test this now? To test this now, all I need is something like a gas lighter like this. So this can create a small flame. So I'm going to light a flame and bring it close to the fire sensor, and you should actually observe the buzzer making a sound. Let's see whether it works. If everything is fine, it will work. Can you see the buzzer going off? It was making a sound. So I remove the flame, the buzzing stops. The moment I light a flame, the buzzer goes off, right? So this is how you use Tinker blocks to build working applications. How much time did it take to me to build this application? Once the blocks are ready, it took me just less than a minute to build this fire alarm application. So Tinker blocks makes it so simple and so easy to build a working application if you have different blocks ready. And you can use these blocks in different projects in different ways, right? It's not necessarily only to build a fire alarm application. You can use this to plonk different kind of sensors, different kind of actuators, and you can build different kinds of applications. Okay, but what I've shown you today is just the tip of the iceberg, I would say, because what I've shown you is very little, just the beginning part of it, how to build a very small project. But that's not all, because if you want to realize the full potential of Tinker blocks, you also need to understand that there are many virtual blocks, virtual Tinker blocks, blocks that help you visualize the sensor data, blocks that help you control an actuator remotely, a web application, a mobile application, IoT application, AI or AR application, or a chatbot application. When you integrate the virtual blocks with the physical blocks, you get to build much more richer applications with Tinker blocks. Okay, that is what will be the topic of our next session, in session 3. And I'm going to show you how to build a few virtual blocks, and I'll also show you how to integrate these virtual blocks like a web app, a mobile app, or an IoT app with the physical Tinker blocks. Okay, so, and apart from this, I'll also show you how to build bigger Tinker blocks, which may have multiple sensors, multiple actuators, and things like that, which will implement a full system or a module, a functional module. Let's take the example of a weather system. If you want to integrate a weather application or a weather system into your project, you can build a Tinker block which has everything that a weather system should have, whether it is a temperature, humidity, air pressure, or whether it is rain status. All of these sensors and actuators can be put together in one block, and that block can be plugged onto your existing project or to a new project. The moment you plug your block, your weather system block, onto a project, that project gets the weather functionality. So isn't it simple? Whether it's so easy to plug one block and you get an entire functionality within no time. That is what reuse is all about. That is what rapid prototyping is all about. You should not build once and throw it away. You should make them reusable so that, and put them into a block so that it can be reused again and again in multiple projects. So these are some of the things we are going to look at in the next session, session 3. All right. And if you want to learn something more of how to build this physical Tinker blocks that I've explained today, please go to this website, or either use this link or scan this QR code, and you'll be taken to this website called Tinker Blocks, where you will find certain tutorials. Click on this link called Tinker Block Tutorials, and in these tutorials you will find step-by-step instructions on how to build the 4 basic types of Tinker blocks. Okay, and I encourage you to go and start building your blocks. And next week I'm going to also show you how to build virtual blocks, and after that I'll give you more tutorials on how to build the virtual blocks as well. And later on you can combine your physical blocks and the virtual blocks and build very rich applications very rapidly in minutes, rather than wasting days, weeks, or months. Okay, right. And finally, if you want to test your understanding of the session 1 and session 2, please take this quiz. Either use this link that I've shown you on top, or scan this QR code, and you will be able to attempt this quiz, and you can submit, and you can see how much you have scored to understand your own knowledge of Tinker blocks. Okay, so that's pretty much what I wanted to share today. So thank you very much for joining for today's session. In case you missed the previous session, please go ahead and watch it. I've shared the QR code for the previous session at the beginning of this session. So go back and scan that QR code and you'll be able to watch it as well. And make sure to join the next session too. Okay. So until we meet again, so happy tinkering. So back to you.
Thank you. Thank you for such an insightful session on rapid prototyping with technical teams. And I really see so much of interest from enthusiasm from the participants that they want to extend the session. We are getting this messages. So yes, we'll be taking questions related to the rapid prototyping, the smart tinkering, and the third session that Sir is going to cover in the third session itself. And we'll continue exploring this powerful concept along with its real-world applications on 5th of December. So we look forward to seeing all our young innovators in the upcoming sessions. Thank you so much, sir, for taking our time. Thank you. Thank you all.
Thank you, Riddhi. Thank you so much for the opportunity to share my knowledge and help the students think better and smarter. Most welcome. Thank you.